Hello everyone, welcome to Maths Club. Today we are going to find the volume of solid generated by rotating a bounded region about the x-axis. And as is the first video, so we're going to start with the disk or washer method. As this is a 3D type of questions, so it will be always easier to understand the concept by using an example. So let's the example is this. Find volume of a solid generated by rotating a region bounded by the curve y is equal to x cube and the line x is equal to 1 and x is equal to 3, and this region is rotated about the x-axis. For this volume of solid kind of question, always we have to start by finding out the region by drawing their graph. So first we'll try to identify the bounded region. So let's start with the y-axis, x-axis, and we're going to draw first the graph of y is equal to x cube. Here is the graph, y is equal to x cube, and this two vertical line x is equal to 1 and x is equal to 3. So this is the region bounded by the lines and the curve and the x-axis. Now this region will going to be rotated about the x-axis to create the solid of the revolutions. Now whenever we want to find out how the solid is formed while rotating a region about an axis or any line, always take the image of this region bounded about the line of rotations. So first we are going to take the image of this curve y is equal to x cube about our line of rotation, that is x. So this is the image of y is equal to x cube. Now to complete the solid, we are going to draw two circular faces, one at this end and another at this end. Now you can erase the rest of the part, and for better understanding we can also shade the faces of the solids first and then the entire solid. Now as we have to use the disk method or washer method, for that we need to take the cross section of the solid perpendicular to the axis of rotation. And here as we have the axis of rotation as x-axis, so we will take perpendicular to the x-axis, which will going to be like a disk. So this is our cross-sectional disk, and to find the volume of the solid, first we are going to find out the area of this cross-sectional disk and then we are going to integrate it to find the entire solid. For better understanding, we will eliminate the rest of the shaded part and we will focus mainly on this our cross-sectional disk. We need to find out the area of this cross-sectional disk. So first we need the radius of this disk. Here this portion representing the radius of this disk, and as this is the distance of the curve from the x-axis, so we can say radius of the disk will be equal to y, and as y is equal to x cube, so we can use this relation between the x and y to finally conclude the radius of the disk as x cube. Now we have to find the area of the disk and then the volume of the disk, and then you have to integrate the volume from one end to another end. As the disk is circular, so you can conclude here the area of the disk so formed is actually area of a circle, delta A is equal to pi r square. We have already found out that r is equal to x cube. So if we substitute this value, then it's become pi x cube the whole square, which ultimately gives us pi x to the power 6. Now, as the width of the disk, which is very small, is parallel to the x-axis, so we can consider the width as delta x. And finally, the volume of the disk, delta V, that is the area multiplied by the width, which ultimately gives us pi x to the power 6 into delta x. And as the disk is moving from the point x is equal to 1 to x is equal to 3, so here we have x varying from 1 to 3. To find the volume of the intersolid, we have to move the disk from one end to another end. So you have to integrate the volume of the disk from x is equal to 1 to x is equal to 3. Now to find volume of solid, we have to integrate the elementary volume of the disk from one end to another end. So the volume V can be written as integration of 1 to 3, the elementary volume of the disk, that is delta V. We have to replace the delta V by its corresponding values. Here keep in mind that delta x in integration have to be written as dx. So finally the integral for the volume become pi x to the power 6 dx. The pi is a constant term which can be taken out of the integral. Now we can use the power rule to find out the integrations. And what is the power rule? X to the power n dx is equal to x to the power n plus 1 divided by n plus 1. So by using this power rule, finally we are getting the value of the integral is x to the power 6 plus 1, as n is 6 here, divided by 6 plus 1, and the limit is from 1 to 3. To find out the volume of the solid, now we just need to substitute the value of the limit here. So the volume of the solid finally become V is equal to, you can write as pi by 7, the 6 plus 1 7 can be taken outside the limits, and the upper limit 3 to the power 7 minus lower limit 1 to the power 7. Now you have to simply calculate these values to find out the final volume of the solid, and after calculations this one comes as 2186 pi divided by 7. So this is the volume of the solid we got by using the disk method. Hope you understood the process. In the next video, we are going to take the volume of solid when rotated about the y-axis. Thanks for watching. Have a nice day.